Hello, Mr. Sutton here, bringing you the AP Calculus 4-9 Extra Practice Number 1 solutions on linearization. On this problem, we're trying to find the linearization of this function here from the point of tangency a equals -2. So we'll start with our linearization formula. L of x equals f of a plus f prime of a times x minus a. And we're going to find, well, a in this case is -2, so we need to find f of -2 and f prime of -2. We'll start with f of -2. That's just going to be -2 cubed, which is -8. And then to get f prime of -2, we first find f prime, which is going to be 3x squared. So plugging -2 into that, we end up with, let's see, 3 times 4, so 12. Putting all that back into this formula here, we can say that L of x equals -8 plus 12 times x minus -2, or x plus 2. On this one, we're trying to find the linear approximation of f of 1.1 given this f of x and a tangent line at x equals 1. So we'll start with our linearization formula, f of a plus f prime of a times x minus a, to convert any function into a line, or at least a linear approximation. F of a in this case means f of 1, which is going to be just 1 plus 1 over 1, which is just 1 plus 1, which is 2. And then for f prime, I'm first going to write this as x plus x to the -1, or at least I'll write it that way in my head. F prime of x then is going to be 1, plus this will be actually -1x to the -2. And then plugging the a value 1 into that, we've got 1 minus 1 to the -2. Well, 1 to anything is just going to be 1, so 1 minus 1 is 0. Putting it back in over here, we've got L of x equaling, let's see here, this is going to be 2 plus 0 times x minus 1. And to find f of 1.1, I'm going to say that f of 1.1 is approximately equal to all of this stuff with 1.1 plugged in. Now, you could leave it like this, but if you need to simplify it, 0 times all this stuff is just 0, so this just comes out to 2. On this problem, we want to approximate f of pi minus 0.1 for this f of x right here, using a tangent line at x equals pi. So to start with, we'll have our linearization formula, L of x equals f of a plus f prime of a times x minus a. And f of a in this case means f of pi, which is going to be e to the sine of pi. Sine of pi is 0, so e to the 0 just comes out to 1. Next, we need to find f prime of pi. Let's start by finding just f prime of x. That's going to be, let's see here, we need a chain rule on this. Our outer function is e to the something, so the derivative of that is going to be e to the something, e to the sine of x in this case, times the derivative of the something, derivative of sine, which is cosine of x. And now plugging pi into all of that, well, we saw earlier that e to the sine of pi was just 1, so we've got 1 times cosine of pi. Cosine of pi is -1, so this whole thing comes out to -1. And plugging it all back in, we have L of x equals 1 minus 1 times x minus pi. Now to approximate f of pi minus 0.1, we can say that this approximately equals all of this stuff with pi minus 0.1 plugged in for x. And if you need to simplify this, well, pi and negative pi are going to cancel. You've got -1 times -0.1, which is positive 0.1. So 1 plus 0.1, that's going to come out to 1.1. For this problem, we're trying to approximate the fourth root of 64 using linearization with a convenient a value. So let's start with our linearization formula, f of a plus f prime of a times x minus a. And we have to pick an a value that makes sense in this situation. It should be something that's easy to apply the original function to, because we need to do f of a and f prime of a. So 63, for example, not a good a value here. But what would be a good a value, something that you can easily take the fourth root of that's close to 64, how about 81? That's the closest fourth power that we know about. So let me find f of a first. That's the fourth root of 81. That's going to be 3. And that's f of 81, not 1. So yep, fourth root of 81 is 3. And then for f prime, well, let's find f prime of x. The f of x that we're dealing with in this case is the fourth root of x, which is really x to the 1/4 power. So derivative of that is going to be 1/4 x to the negative 3/4. And now if I plug in 81 for that, well, I'm just going to put this back in radical fraction form to make it a little easier to evaluate. So this is going to be 1/4 times the fourth root of 81 cubed. And what does that come out to? Well, fourth root of 81 we already saw was 3. Cubing that gives me 27. And 4 times 27, that's going to be 108. So this is going to be 1/108. Okay, plugging it all back in, we can say L of x equals 3. That was the f of a that we just found. Plus 1/108 times x minus 81. And now to actually approximate the fourth root of 64, we have to plug 64 in for x in this linearization formula. And we're going to write approximately equals because this is not the exact value. So let's see here. This is going to be negative 17 in here. So we can write 3 minus 17/108. And if you really wanted to combine those, you could call this 2 and let's see here. This would be 91/108. There we go. For this problem, we're trying to approximate y equals radical 4 plus sine of x at 0.12 using a tangent to the graph at x equals 0. So let's use our linearization formula. That's L of x equals f of a plus f prime of a times x minus a. F of a in this case means f of 0. So that's going to be the square root of 4 plus sine of 0. And let's see here. Sine of 0 is just 0, so this is the square root of 4, which is 2. And now we also need f prime of 0, but first we need f prime. So I can think of the original function here as just 4 plus sine of x to the 1/2 power. Derivative of that's going to require the chain rule. That's going to be 1/2 times 4 plus sine of x to the negative 1/2 times the derivative of 4 plus sine of x, which is cosine of x. Now if I plug 0 into that, I can write the cosine of 0 in the numerator, and down below I'm going to have 2 times all of this stuff square rooted with a 0 plugged into that sine function. Simplifying this, cosine of 0 is 1. Down below we have 4 plus sine of 0, which is just 4. Square root of that is 2, times the other 2 gives us a 4 again. So when the dust settles, we've got 1/4 for f prime of 0. Plugging all that in now to our L of x, that's going to be 2 plus 1/4 times x minus 0. And we wanted to approximate 0.12, f of 0.012. 0.12, there we go. So that's going to be 2 plus 1/4 times 0.12 minus 0. And they do want us to go all the way on this one if you look at the answer choices. So a quarter of 0.12, that's going to be 0.03. 2 plus 0.03 is just 2.03. So that's our answer, choice B. On this one, we have a function g that's differentiable and satisfies all these conditions. And we want the approximation of g of negative 1.2 using a tangent line at x equals negative 1. So let me write out my general tangent line linearization formula. L of x equals, and in this case we'll call it g of a plus g prime of a times x minus a. Usually I write it with an f, but I'm making it all special for this problem here. So g of a in this case really means g of negative 1. And g prime of a, that's g prime of negative 1, and this should be x minus negative 1 or x plus 1. So this is what we're going to try to do in just a second. Now the good news is I have values for all of these things. G of negative 1, they told us up here is 4. G prime of negative 1, they told us up here is 2. And if I'm trying to approximate negative 1.2, then I have to plug that in for the x in here. So this is negative 1.2 plus 1. And we are going to have to simplify this without a calculator. So this is going to be, let's see here, negative 1.2 plus 1, that's going to be negative 0.2. And then 2 times that gives me negative 0.4. 4 minus 0.4 is going to be 3.6. So that's giving me choice A. On this problem, they're telling us that f is some differentiable function, which they're not showing us. What they are showing us above in this graph is the line tangent to the graph of f at x equals 0. And they want to know which of these has to be true. So we have all sorts of comparisons between f prime of 0 and f of 0. Now the key on this one is recognizing that a tangent line at x equals 0 is basically giving you perfect information about the function's function value and its derivative at x equals 0. We know the value and the slope of f at that x value. So looking at the graph, f of 0 then is whatever point we're going through on the y-axis, which is negative 2 in this case. F prime of 0 is going to be the slope of the whole tangent line, which is, let's see, down 2 over 1, that's also negative 2. So comparing these two things, we see that f of 0 and f prime of 0 are the same thing, which would give us answer choice C.